One of my first goals is to get the particles moving down instead of up. And in ice, there are some tasks that accomplish this. If you look under the forces category of tasks, we have a number of forces such as gravity, wind. We can use points as a force or another object as a force. We can even use neighboring particles to help control flow of particles and certain types of forces. So what I can actually do here is I'm going to bring in an add forces compound, which initially, if I double click on it, provides me a vector in which to point the particles. I want this to execute every frame, so I wouldn't add it to the emit from surface compound. I would add it as a new connection in the ice tree. So I'll connect it to port 3 because I might want to do something to the particles before I add forces to them, maybe change their size or change their color. So I'll leave port 2 open for now. Again, this is all irrelevant because I can always add ports in as I see fit. So if I double click or just press play, actually play in the user menu, and I set, let's say, a vector of -9, I can actually pull all those particles down on the negative y-axis. But in this case, I have a node that does this for me, or a compound rather that does this for me. You can see it's the gravity force compound, and if I open it up, you can see that it does a little bit more than just use a directional vector to calculate how fast an object is going. It actually takes the mass of the object into account as well, and then multiplies the magnitude of gravity by the mass to get a sense of the object's speed or its displacement. So I'm going to take the gravity force and output its vector output into the add forces input. So that'll basically have the same effect, but now I'm actually using the mass of the objects as well. The mass, by the way, if I double click on the emit from surface compound, is 0.1. It's not varied at all. All of my snowflakes are going to have a very low mass. If I vary it up, I might do it at the very end, just to add a little bit more variety into the simulation. But for now, I'm going to leave the mass constant, 0.1. So we're getting some movement.